Even though it has no mass, light carries enough momentum to propel satellites and spaceships. We'll take you sailing on waves of a different kind this week on Light Matters. This is Light Matters for May 27th, 2015. I'm your host, James Lowe. On this week's show, we'll explore two projects that aim to use light as a propulsion system. We'll also look at a new approach to growing optical components, and this take on a recent silicon photonics advance from contributing editor Joey Esposito.
If you're like me, there are many nights and weekends spent lounging on the couch, binge-watching TV shows on Netflix and Hulu. Well, I'm happy to report that engineers at the University of Utah have taken a small step towards a technology that could result in a significant increase of computing speed, streaming devices included. These engineers have created the smallest ever beam splitter, less than 2.5 square microns in size. Described in Nature Photonics, the device divides light waves into separate channels, which brings them one step closer to the production of silicon photonic chips that would process data with light rather than electrons. Data can be transmitted through fiber optic networks, but that light has to be converted into electrons before it can be used by a device, a problem solved by keeping the data as light within the device, which is where silicon photonic chips come in, with this new ultra-compact beam splitter, making them small enough to fit in an average device is closer to reality. Silicon photonics would do wonders for server technologies or drones, but also potentially consumer-level tech like video game consoles and our coveted streaming devices. It would be cost-effective because it uses microchip fabrication technologies that already exist, but it also cut down on the amount of power that these devices use. If this means I'll never have to wait for the latest episode of House of Cards to buffer before diving in, then I'm all for it.
Thanks, Joey. Next up, Industrial Photonics editor Rod Pedrati takes a look at a new approach to growing optical components.
A team at the University of Pennsylvania has figured out how to control the formation of smectic liquid crystals into compound lens arrays similar to insect eyes. The lenses produce sets of images with different focal lengths, a property that could be used for 3D imaging. And unlike other liquid crystal lenses to date, they're sensitive to the polarization of light, a quality thought to help bees navigate their environments. Now, to make the lenses, the researchers used photolithography to fashion a sheet of micropillars, then spread the liquid crystal on the sheet. At room temperature, the liquid crystal adheres to the top edges of the micropillars, transmitting an electric energy cue that causes microlenses to line up in concentric circles around the posts. Now, depending on their size and position, the microlenses have focal lengths ranging from a few microns to a few tens of microns. Because of this parallax effect, an imaging device with this kind of lens array could be used to gather 3D data. The research was published in Advanced Optical Materials.
Thanks, Rod. Coming up next, two new projects hang 10 on some gnarly electromagnetic waves. But first, this word from our sponsor.
My name's Susanne. I'm a product manager at GreenTech, which is a Swiss-based company that produces thermal laser power detectors. If you want to find out more about our products, have questions or ideas on how to use them, please visit us on our webpage greentech.com and just ask your questions. We will be happy to find a solution for you. Thank you.
Welcome back. Light carries a tiny amount of momentum, and that force is being put to use by two experiments that could have major implications for spaceflight. YK Bay Corporation of Tustin, California says it successfully accelerated a 1-pound mirror along a 2-meter frictionless air track using its photonic laser thruster technology. Infrared photons bouncing back and forth between the mirror and a laser built up to produce a thrust of 1.1 millinewtons. The company said this kind of laser thruster could be used for keeping satellites in position in orbit around the Earth. It's now working on scaling up the technology and making it spaceworthy. The project was funded by a $500,000 Phase 2 grant from the NASA Innovative Advanced Concepts program. Meanwhile, the Planetary Society last week began a test flight of its LightSail spacecraft, which features a 344 square foot Mylar solar sail. This mission will test LightSail's critical functions in low Earth orbit before a second mission, set to launch next year, takes another LightSail module into higher orbit for sustained solar sailing. The roughly $5.5 million project is being funded by the Planetary Society and contributors to a Kickstarter campaign launched earlier this month by science educators Bill Nye and Neil deGrasse Tyson. LightSail is based on a CubeSat, a lightweight module about the size of a bread loaf that's been used in a variety of space experiments in recent years. When its 4.5 micron thick solar sails unfurl, LightSail will grow to about the size of a boxing ring. Even though the light from the sun will give the solar sail only the smallest push, the idea is to build up speed gradually over time until it's moving faster than a chemical rocket could. If LightSail works as planned, it could open up a new renewable mode of space transportation. And speaking of sun-powered travel, a solar airplane we introduced you to back in March is continuing on its round-the-world journey. The Solar Impulse 2 is currently grounded in Nanjing, China, waiting for clear skies to begin its 5-day non-stop flight to Hawaii. We'll keep you posted on its progress. And that's it for this week's edition of Light Matters. To keep up with the latest industry news throughout the week, join the Photonics Media discussion group on LinkedIn. Thanks for watching, and we'll see you next time.